What are the laws of the universe? Well, here we'll start with this corporation, really an association. They give money out, so if you want to stand in line, please do so. Okay, and they're known as the Alfred and Sloan Foundation. What do these people do? Well, they give money out. They say together, and here it says science foundations, right? Fund. Okay, they talk about science. They say this, what they're going to say next is science. Okay, physics that could transform our understanding of the universe. Well, if you go in here, these people say, look, we're giving money out for projects that help us understand the universe, meaning physics, meaning science. Is that what these people do? Well, I don't think so. And you can see where they're giving their money. And look at some of the projects these people have. Okay, here's a list of them. Okay, one first group there says colleagues will build a what? New experiment to search for proposed ultralight particles called axions that could be part of mysterious dark matter that makes up roughly 85% of the universe. Okay, another fellow says team will measure whatever. And the other one team says we'll use a powerful superconducting magnet. They're going to run an experiment of some kind to search for proposed ultralight particles. The other group there implement a powerful new approach to finding instances in nuclear interactions. Interaction, what does that mean? They're going to run an experiment. And last one there, lead the development of ultra-precise atomic clocks to perform some kind of experiment, blah, blah, blah. Okay? That's the first group that's going to receive these $30 million that they're allocating for these projects. And here's another set very quickly here. It says, we'll develop a method to form trapped gas. The other one says, magnetically levitate diamond crystals. The other one says, again, development of nano diamond spatial interferometer, etc., etc. All these people are doing experiments. And so the Sloan gives them money to run these experiments. And what's the purpose? To come up with some kind of technology. So they say, we have more advanced technology now. We can do this, we can do that. We've learned how to do this because we can describe it mathematically what happened. Do they understand what they did? Do they understand how that happened? What the mechanism was? What caused it to happen like that? Absolutely not. So they're not doing science or physics as Sloan advertises itself. All they're doing is giving money for experiments that have to do with technology. None of that has anything whatsoever to do with physics or science. Okay? Physics, science, first, rational explanations, and physics is a branch of that, and it's rational explanations of causes and mechanisms. Okay? And these people have nothing to do with explanations, let alone of causes and mechanisms. Okay, so one fellow says, kind of puts the icing on the cake. He says, frankly, physicists, mathematicians, and scientists don't care about the philosophical interpretation. He says philosophical of the word field. Yeah, no, we're not talking about philosophical. We're talking about physics because they're introducing field in physics. And this is not an issue of philosophy, of word wizardry or word salad or semantics. This is an issue of, if a field is a physical object, please point to it. And he said, they don't care about that. Yeah, and that's why we're where we're at today, where we have no understanding of how this universe works because they never addressed, the physics of it, the physical interpretation, the causes, the mechanism. We don't know, or they don't know, the mathematician, they don't know why this pen falls to the floor. They can't tell you something as simple as that. And we've known about gravity, I guess, since man had use of reason. Okay, so yeah, science is rational explanations and physics is rational explanations of causes and mechanisms. Okay, you have to explain. And so he says that, physics allows you to see the world through the eyes of mathematics. Yeah, and it doesn't allow us to see the world because we have no idea. Well, they don't, at least we do here, but they don't have an idea how this universe works. And mathematics is not going to give us any insight into, how this universe works. Here's an engine, how it works. Is this part of physics? I mean, it gives you a rundown what the piston does and so on. And this is just a small part of a car, of how a car works, But essentially, that's what we're expecting for these people to do with gravity or electromagnetism. They don't do this. They don't tell you. And the question is, what you're staring at, this explanation you see, is that part of physics or is that part of philosophy? So that's the question for you. If it's part of physics, you should do the same thing for gravity and electromagnetism. No reason why you should not. Those questions are part of physics. The only reason they have not made it part of physics is that they never identified the invisible, intangible objects that mediate those transactions. Okay? That's the only reason. There's no other reason. Okay, here you see a supernova. This came out of a mag that just came out, an article. Beautiful. Is this physics? Is this science? This looks more like art to me. They just put a picture there and they say, oh, look how beautiful. We took it with one of our telescopes out there that's on a satellite or whatever, It's out there in running around the universe just taking pictures. Okay, so we see a picture. Is this science? Just a picture? I take a picture of my dog and that's science? I mean, this is absolute nonsense. Here's another picture. This is what they say is science. And you see this constantly everywhere. And these are in the articles. And they show you these electrons, beautiful pictures. I'm not going to complain about the art. They're absolutely beautiful. But is this science just putting, some pictures there? Okay, and then they describe it and they try to say this is what an electron is, this is what an atom is, etc. But the question is that what an electron is? Is it a little ball? Is it a little bead that rolls around the atom along the energy level or whatever? The shell. Here's another picture, real quick here. Again, you can see it says a localized electron absorbs a photon. So a photon, which is zero-dimensional and is only energy, as far as they're concerned, they're saying it's a packet of energy. How did it absorb a concept? I mean, if it's a bead, you could say it absorbed the bead. We can all understand that, My kid, takes a deep breath and swallows some sand. So he has some grains in his mouth. That we can all understand. Oh, a grain went into his mouth. But to say that a photon, an energy packet, went into an electron, which again, they don't have the slightest idea what it is. They've never taken a picture of one. So is that what science is about? Just saying that an electron swallowed some energy, whatever that is. Okay, so this is the problem. This is the starting point. And here you have one individual. He's a caricature of a scientist. Actually, really more like a clown, I would think, because of what he proposes, the way he thinks, calls himself a physicist. No, he's a clown. He's just there for entertainment. He says the laws of physics are mostly equations. Mostly equations? That's what a law is, an equation? Imagine if you put an equation in the legislature and say, hey, we want you to put this as law number 1. Okay, so we have an equation. If you violate the equation, you go to prison. Okay, great. It says, like Maxwell's equation describing electric and magnetic fields, Einstein's equations describing gravity, beautiful equation. Yeah, I don't care about beautiful. Beautiful is a woman, not an equation. Totally precise and really describe what nature does. Okay, somehow nature knew that and does what the equations say. Okay, so it follows the equation because again, an equation is a tautology. In a sense, it's geared, it's made, tailor-made to what these folks observe there. So they say, look, the Earth goes around the sun, and we observe that. Here's the equation, and great, because the equation had better depict what the Earth is doing. But so far we know nothing about explanations. All we have is, an equation that describes the path of the Earth around the sun. So what is that? Is that something that's beautiful and that's also a law? What kind of law is that? What are we talking about? And that's something quite unique. But then he says there's nothing like that in biology, chemistry, or anywhere else. In the rest of science, you have emergent laws. They come into being, these laws, Whereas the physicists or mathematical physicists, they claim to be describing with equations what they observe out there, in the night sky. Okay, so here we have this same fellow. He continues this. Philosophers say, sure, these equations work, but they really don't represent reality. That we're never going to get to the real reality. Well, that, of course, that may be true. I would be at all surprised if it turns out that everything we're doing is sort of very partial, and that there's a whole world of existence out there of which we know we haven't an inkling. And yeah, they have no inkling whatsoever of the rope model. And once you have that, then you get rid of all of quantum mechanics and general relativity, of the physical interpretations of those two religions. That's where that's the part that he's missing, that he's never been acquainted with something like this, a different idea, and they'll never allow this idea to enter the mainstream. They're going to fight it all the way because everyone's been educated, if you can call that, to use what their forefathers told them, which is all this quantum and relativity nonsense and string theory. So he continues, so I wouldn't be at all surprised if our science in 1,000 years looks extremely primitive. No, he doesn't have to worry about that because our civilization, humans, are about to become extinct. We're not going to be here in 1,000 years. So he's run out of time. They never figured it out. I don't regard what we have now as final. Yeah, there we agree. Physicists would say that laws are the reality. Okay, the laws meaning their descriptions. We understand the physical world extremely well. No, you don't understand it at all. Again, Dyson does not understand a single thing. Understand means that you can explain. That's understanding. But to say you described it with an equation, okay, so the chair has 4 legs, 1 seat, 1 backrest, and maybe, 2 armrests. Great, you described the chair. Is that science? Is that a law? Is that what we're talking about here? The law of the chair. Okay, so here we have some of the laws that they're talking about. One is or we can say 3 of them are the laws of motion, so-called laws of motion, so-called or supposedly discovered by Newton, which is not true either because all these came from different people before him. Okay, but he kind of put them there and he got the credit for it. And it's very simple, law will not, an object will not change its motion unless a force acts upon it. The second law, which is probably the most important one in his group, force is equal to mass times acceleration. And then the third law, the action and reaction, essentially. Okay, so those are laws. They call them laws. I don't know what they mean by law. Can I break the law? I mean, if I can't break the law, was it a law to begin with? What do you mean by law? You're just describing and saying this is a fact. This is the way it is. This is the way the universe runs. Is that a law? Does that qualify as a law? What is a law? We have no laws in physics, but this fellow apparently believes we do, and he's not the only one. There's a whole bunch of people out there who believe in these laws and I guess obey the laws, whether they like to or not. Here's another law, in Kepler's law. He told us how the planets roll around the sun. They don't roll around in circles. They roll around in ellipses, right? And so there you have them, very straightforward. I think most of you are acquainted with them. Nothing fancy today, at least. It was a breakthrough at the time because for him it was a big deal. He was using his eyes. He had no telescope. He was using the information collected by his ex-boss, which was Tycho Brahe, and so that's what he used. So it was a breakthrough at the time. But to say that now that those are laws, what do you mean law? You have to explain why the planets are going around in ellipses. Why? What's the cause? And of course, they can't. They just say they do. That's all Kepler told us. Okay, here you have another law. It's a set of laws, you could say. It applies to gravity and light. And the first one is the one on the left. Gravitational attraction force between 2 point masses is directly proportional to the product of their masses and inversely proportional to the square of their separation distance. the force is always attractive and acts along the line joining them. Okay, so, the farther away you are, the lesser gravity, the closer you are, the more gravity. Okay, yeah, that's a description. Why? What's the cause? It turns out for light, it's exactly the same, or more or less the same. The intensity of the light to an observer from a source is inversely proportional to the square of the distance from the observer to the source. Again, the farther away you get, the less intensity of the light, and the closer you get, the more blind you become. Great. So you can see both these, the gravity and the light, the electromagnetic, I guess, aspect of it, they're both square of the distance. So what is the cause of this? What causes this? Because it looks like, we could merge these two, light and gravity, into a single mechanism. And yeah, under the rope model, no problem. The farther away you are, the ropes tend to come together. So it's that same thing. The one in gravity on the left should be in reverse if we're saying that the closer you get to the Earth, right, the wider the more the ropes fan out, and the farther away, the closer they come together. And for light, it would be the same thing. The closer you get to light, right, the more intensity means that you have from light going through every rope. Whereas the farther away you get from the rope, from the light bulb, the ropes come together and they form a single coaxial. So if you just turn around those two square of distance representations, just turn them around, and then you'll get an idea why the force of gravity is stronger closer to the Earth and why the intensity of light is closer to the bulb. Very simple. Okay, so we do have an explanation for that. They've never explained it. Tell me why. They just say it is so. Why is it so? Well, the energy is flowing, a field or whatever. No, you can't use those words. You got to tell us physically what's going on. Okay, here we have another set of laws. These were, you could say, formalized by Mr. Maxwell, but he stole them from other people. Okay, here we have Gauss's laws. One is the electric field points away from positive charges and towards negative charges. Great. I mean, well, it was news in the days of Gauss, right? But it's not news today. Magnetic field lines never begin nor end, but form loops or extend to infinity, wherever infinity is, right? Electric charges have no magnetic monopoles. In other words, if you cut a magnet in half, like you see there on the right, lower right, you'll find that it has a north and a south. You can never isolate the north or isolate the south. And under the rope model, that's very easily explained, okay? And that is that, we've explained that in the past. You have to look up one of the magnet videos. It's kid stuff. It's really no biggie. You have the threads just flowing inside the magnet, like more or less like tank chains, the tracks that they have. And you put one tank against another tank, right? And they're both going like, let's see if I can do this, going like this and inwards and like that and inwards. That's what they're doing, okay? Like one tank sitting on top of another tank. That's upside down. Okay, so they go like this, and the one on the bottom goes like that. So they all go through the center, come out, and then again, come in through the center and so on. And that's why you cannot chop. Anytime you chop it, you will still have the same pattern, like this. That never changes. Why? Because the rows of atoms, right? They're swinging the threads, which is what is going around the threads, the magnetic field, right? They're moving around the walls of threads and coming over and around and coming over and around. If I cut that in half, I still have the same, the atoms that are still there doing the same thing. That's why you cannot isolate a monopole, ever. It's irrational to try to do so. But the mathematicians and the technologists, they keep trying. Good for them. Okay, then we have Faraday and Ampere laws here. The changing magnetic field induces a voltage, and magnetic field lines encircle the current carrying wire. They lie in a plane perpendicular to the wire. If the direction of the current is reversed, the direction of the magnetic field reverses. The strength of the field is directly proportional to the magnitude of the current. and the strength of the field at any point is inversely proportional to the distance of the point from the wire. Okay, and these are what they call laws. What they're talking about when they say laws, they're talking about the description, the mathematical description of these physical phenomena. But they cannot tell you what a field is. They use the little b there, and the big B, really, capitalized B. And what is the B? So they say, well, that's that's a mathematical concept that we're going to use that's twirling around. No, mathematical concepts cannot twirl around. Okay, so and again, they show there on the upper left an ammeter, right? And what's it doing? It's they're putting a magnet inside a coil and saying, look, it just increases the force, the field, etc. And so what? That's like saying I can pick up iron filings with a magnet, and you haven't explained the mechanism. That's what we want to see. And so again, all these laws are just descriptions, but they, it's like these are laws that are signed in the Constitution of the universe, and we are not allowed to violate them, even if we wanted to. So what, did God make those laws? That's why we can't violate them? And if you do, what, you go to heaven, hell? I don't know. Okay, and here's another law known to a lot of you, okay, the thermodynamic laws, okay. There's several. I'm just going to talk about two of them. Energy cannot be created or destroyed, known as the conservation of energy. And the problem there is that we don't know what energy is, has no idea. Second law, more or less the same thing. Heat flows from hot to cold. Great. Entropy is a measure of disorder. That's an opinion. How much disorder there is, it's a question of opinion. But they put a number on that opinion. They say, oh, there's more disorder here than over there. More entropy, right? Tends to increase in isolated systems. The law explains, no, the law does not explain, but says why processes are irreversible and defines the arrow of time. Well, I don't know what the arrow of time is. Never got hit by one, unfortunately. Okay, no engines in my side of the world, so I don't know. I never got an arrow in my back, especially. A lot of bullets, but no arrows. Okay, another law of the universe. Some of you are familiar with it, and that's the black body radiation that Planck discovered. If you put a box completely empty inside, or you have even something in the box that doesn't, you can have a black ball inside the box. They're saying no matter what, no matter how isolated that system is, there's always radiation coming out. And you say, how can that be? I haven't touched it. I haven't moved anything. It's completely protected, and it still has radiation. Well, in the rope model, there's no problem. The ropes extend right beyond the wall of the box, all the way to the atom on the other side of the universe. So all the ropes are coming out of whatever's inside the box, any atoms that are in there, and it's going to every atom in the universe. Even if you remove everything from the box, you have them from the walls of the box in every direction, all the atoms that form the walls of the box, and those ropes are extending to every atom in the universe. And energy, that energy thingy that they don't know what it is, it's a bunch of ropes that are, torquing. And so, you're going to have energy even in a black box, because what you're doing is having all those ropes from every atom that forms the walls of the box go everywhere to every atom in the universe. So there had better be energy inside the box, meaning, a bunch of ropes that are torquing. That's all that energy is, the torsion of gazillions of ropes. There had better be energy in there, if that's what energy is, right? Okay, here we have another one, Schrodinger's equation. Okay, it describes how the quantum state of a physical system changes with time. And this I took out of my book. You can see we can explain Schrodinger's equation without the nonsense of a little bead rolling around a proton center. And it relates to these quantum numbers. What do they represent? You have the NLMS, and you have them here. N represents the distance from the electron bead to the nucleus. Okay, and we say that the electron is not a bead. We're saying that it's a membrane, so you still have a distance from the center of the proton, which is a star, to the edge of the atom. So we're covered on the letter N. How about the letter L? Is the azimuth, latitude, or meridian. We have those also as well around the shell, the membrane that encapsulates the proton. No problem there. How about the M? longitude or parallel. Okay? And again, what we have there is the same thing. We have all these elements in the ball that surrounds the center of the atom, which is the proton star. And then finally, S is a weird static dynamic concept. They never figured out what spin is to this day. That misleads people to think that the electron ball rotates like a top. It doesn't. That's not what quantum says. Actually, the mathematicians talk about what spin orientation and describe two possible states as spin up and spin down. In other words, what these people have is a top that spins upwards and downwards, whatever that is. Yeah, it doesn't spin at all. They use the word spin, which is very misleading, and they call this a law. The atom spins or the electron spins or whoever spins. What do you mean spin? Spins like a top? They say, well, not exactly. It's orientation. It's a spin orientation. It's like, let me give you an idea. You mark your top. You put a little line on your top, right? Or paint it or whatever, right? And you twirl the top. Well, the line will go around, right? And what these people are saying is, look, the top goes around, whether it does or not, but the line always stays there. And you can say, oh, this is spin up, or that line that you made is a measure of the spin. It doesn't move. It's a static concept. So spin in quantum mechanics is just like a mark that you made on the top that doesn't spin with the top. In fact, the top doesn't spin either, probably, but they're not clear on that. But even if the electron spins, the line does not, because it's an orientation. It's a mark you made that does not move around with the electron. Okay, here we have another one. This is good old special relativity. We have that as well. That has to do a little bit more with the universe, not so much as general relativity, but yeah, they do talk about traveling to other stars at the speed of light, etc. And so here you have special relativity as an explanation of how speed affects mass, time, and space. Okay, I cannot imagine how speed affects any of those three concepts, because speed itself is a concept. So concepts affecting concepts, that's what they're going to talk about. Speed of light defines the relationship between energy and matter, whatever that means, okay? In an equation, yeah, no problem, but what does that mean physically? Okay, that's what we're talking about. How does matter interact with energy if energy is a concept? Okay, so how can speed of light, which is a concept, dynamic concept, affect energy, which is another concept? And here we have small amounts of mass can be interchangeable with enormous amounts of energy, as defined by the classic equation E equals mc squared. Okay? And the speed of light in a vacuum is constant. Okay, we do agree with that last statement. We make the same assumption. Okay, and we explain why under the rope model. You take any rope and you twine a pair of threads. I've got one here. No, I don't have one readily available. Oh, okay. Let's see, maybe I can do it with a string. Okay, give me a second here. Okay, we're gonna. Okay, so here we have a rope, right? Two twined threads or pair of threads. Okay, and if I torque it more, right, for the same amount of thread, right, for the same amount of thread, I get more links, and each link is shorter. The size, the length of the rope has not changed. And vice versa, if I untorque it, right, I get fewer links, each one is longer. And there you have the equation of light. C equals frequency times wavelength. Frequency is the number of links. And wavelength is the link length. So one is inversely proportional to the other. Very simple stuff. With a rope is the only way you can explain it. In other words, C equals frequency times wavelength, C being a constant, 300,000 kilometers per second, is the equation of a rope. That's the only entity that can simulate light, electromagnetism. Okay, here we have general relativity. Why not? I mean, we had special relativity. Why not general relativity? What is that? Well, it says that massive objects warp the fabric of space-time, causing other objects to move along curved paths. And this ridiculous thing, why is it ridiculous? Well, because you have the sun weighing down number lines. Those lines that you see there, those are number lines. And that's math. That's got nothing to do with physics. There are no number lines out there in space. But this is the mechanism they propose. They say the sun weighs down the number lines, especially the number line known as time. And because time is warped, it's bent suddenly, the Earth cannot fly out of the solar system because there's this wall of curved time that blocks its exit. You need a lot of beers to understand that. Okay, but that's what they're proposing. Okay, so these are the laws. There are a couple more. Okay, I think I covered quite a few of them, but what they're referring to is equations. Okay, in fact, one of the visitors just now, about a little while ago, put it up there. It says, what is meant by laws is principles derived from observation of objects and what they do, cause and effect. Law does not mean there is something directing behavior as such. Yeah, these are just mathematical principles, if that makes any sense in math. It has no bearing on physics, but that's what they are. They're just equations. And these people call those equations or set of equations, right, as laws. They say the laws of physics, the laws of the universe. What do you mean the law? Means you can't break it, Bill. Okay, I can't break that law. And what does that mean? It's like you're stating a fact. You're stating a fact that, this falls to the floor. Okay, it falls to the floor. Is that a law? I can't break it. Okay, I can't break it. Is that a law? Well, what do you mean? Laws hopefully are things that you can at least attempt to break. I know a little bit about that. Okay, you try to break laws. You say, I broke the law. Now I go to prison. If you break one of the laws of physics of the universe, do you go to heaven, hell, or you get punished? I don't know. If you obey them, you go to heaven. you don't obey them, you go with the devil. I don't know. Okay, so let's give some conclusions here. Okay, so-called laws are equations. Let there be no doubt about that. So they should say the equations of the universe, which are descriptions of something that is fixed, that you cannot change. Okay, and a lot of those, like in the case of quantum mechanics and so on, are based on the particle model. So whether those laws are laws in the sense that they mean them, they simulate them with particles, that's the way they imagined them. The question is whether those laws can be, you can take that to the bank. And I'm saying you can't, because if what's really in that invisible world are torsions, if what's in there are ropes, or in the case of electricity, the merging of a bunch of electron shells that are twirling in situ, then you cannot talk about speed in the sense of, the little electron bead went from A to B. No, you can say the torsion, creating torsion here as an object, the signal that you detected, that went from A to B. You sensed a difference in timing from the time you torqued it to the time that you measured it. That's different than saying a little bead moved from A to B. And so the question is, when you talk about laws, we got to look at the context. Otherwise, what are you saying? You're saying a little bead, went from A to B? Maybe that's not what happened. And so the law has to be put in the right context. These laws are irrationally explained with what? Unimaginable physical interpretations and irrational mechanisms / causes. Yeah, all coming out of mathematical physics, whether it's quantum mechanics, general relativity, or string theory, they only have irrational explanations. There's not one rational explanation in all of mathematical physics with respect to the invisible, intangible mediators that Mother Nature uses, the things that these people have yet to find out after 10,000 years, which is how gravity and electromagnetism work. That they have never figured out. Laws of mathematics are intended for technology and are not designed for understanding how the universe works. Job of a scientist is what? To explain rationally. These people do not explain rationally. They are not scientists, let alone physicists.